And ladies and gentlemen, Jada here with Timber and Anvil. Kind of a short video. I wanted to capture a few projects I've been working on lately. First and foremost, this big, beautiful piece came from where my blacksmith shop used to be in another building on my property, sort of a lean-to building. So I had three walls and a roof. So the eastern side was totally exposed. That was before I moved into this building last fall. But this is a antique hand crank drill press that I restored about almost 3 years ago. Cleaned the whole thing up, soaked it in simple green for about a week or so, which fabulously cleaned all of the rust and funk off of it. And then I proceeded to grind things up where there was nasty casting flash from the original manufacturer, and then painted it. Did a little bit of pinstriping. I need to clean this thing because it was sitting in that exposed building and got really filthy and dirty. So it's not quite as glorious as it once was. But I just had fun with it, pinstriping by hand. I'm not an artist, but I was, again, just having fun. And this little knob here, I actually, I 3D printed a mold for this, and then at a friend's shop, cast it in bronze. And I cast it with a stud on the top, which I pre-planned. I intended that so that I could chuck that in the jaw of my little 618 Atlas lathe. And then I turned it on the lathe and got, the shape was largely already there, but I just had to essentially sand away, file away the 3D printed sort of texture, and then cut threads on there, so it's actually threaded through. I've got a thrust washer on top and bottom. Sorry, it's not focusing right. But thrust washer on top and bottom so that it spins freely. And this is the depth advance, so that if your workpiece is really thin, you can quickly chase this down. And then similarly, when you're done working on your piece, you flip this pawl up, and now I can crank the drill back up for the next piece that I'm going to cut. So it works out great. These are parts of this drill press that I forged myself. So I forged this little pawl, which unfortunately is not as loose as it should be. And then I forged this toggle arm, which that's another sort of mistake or failure to plan. It needs to be heated up again and bent back that way a few degrees so that it comes back on the stroke further than that, because that right now is as far back as it goes. It needs to come back several teeth rearward of where it is right now. But this thing runs on a cam, so this boss, the hub of this flywheel, a solid cast iron flywheel here, is out of round intentionally. It's a cam, so that you can see it lifts and lowers that arm, which then corresponds to advancing these teeth a little bit at a time, which then corresponds to dropping the drill bit, or rather feeding it into your workpiece. So unlike a traditional drill press that you're used to these days, where you manually crank a lever to feed it into your stock while a motor is spinning it, this does it in one single motion. As you're cranking the drill, it's going to automatically feed the bit into your stock, and you can see it is advancing there. Kind of doesn't quite work as well because that thing sticks, but you get the idea. But anyhow, I had to throw magnets on here because I should have forged this bar, or this section of the bar, much longer to counteract the weight of everything on this end of the pivot point. So it would automatically ride the cam. Because there's more mass on this side of the pivot than there is on this side, it doesn't normally do that, so I threw some rare earth magnets on there. Anyhow, I need to finish cleaning that up, but I anchored it with lag screws to what was originally my anvil stand for quite a few years. It's a 2-foot cube made out of 6x6 timber, pressure treated and lagged together. And it served as my anvil stand for the 85-pound Peter right there for quite a number of years. until finally I upgraded the stand to the tripod fabrication. But it served its purpose, and now it's serving a different purpose in the shop, providing a bit of a ballast counterweight so that I can crank on this thing, and it's still pretty solid. I mean, I can move it, but it's anchored quite well. I'm going to zip the top of that off with a Sawzall eventually, because it's unnecessary. But anyhow, projects that I've been forging. So I forged this rather beautiful punch, I think, out of 1065 from a coil spring. It was like a railroad track coil spring, and about 1 inch diameter. And typically in forging material, you go square, then octagon, then round when you want to round something up, because making a round thing is all about just eliminating corners. Well, on my punches, I prefer a hexagon, and in this case, I deviated and went with an octagon because I've never really made a punch with a nice, clean, uniform octagon where all 8 sides are pretty well, the same width face. I did minimal cleanup on the belt grinder just to get scale off and get a nice uniform finish, but that was a lot of fun, and I'm quite happy with how it turned out. It's a nice slitting chisel for doing, like chiseling in grooves on a square bar for doing a more ornate twist. So that's that. This is a very, very special piece. It is a nail header, laminated construction. So this sort of button here is 1065 from another railroad spring clip. And it is forge welded onto a length of bar that is wrought iron from a Lake Michigan, Milwaukee area pier that a friend of mine, his brother, does demolition, and he got these humongous bolts that were like 1.5 inches in diameter. And so I heated this up and forged it out with a friend's power hammer to this more or less square dimension here, and then I folded it over on itself, split it a couple inches back, about 90% through, folded it over on itself, forge welded it to get a little bit more mass, and then flared it out so that I could fit the 1065 button on there. And the thing that makes this very, very special isn't that it's wrought iron from a historic Milwaukee, Wisconsin pier. What makes it special is that you guys might have heard of the TV show Forged in Fire. Well, I think this is one step beyond that. This is forged in tornado. I kid you not, this past Saturday, June 22nd, 2024, a tornado came a half mile north of my house. And I was working in the shop. Weather seemed fine, and then suddenly the weather was very much not fine. My shop has an exhaust fan up there that has, because I was forging in coal, so I run that. It has louvers, which free flap. And I started hearing thunder. I looked outside. The sky really didn't look threatening. And so I kept working. And then all of a sudden, those louvers started absolutely going ballistic. And during the daytime, from where I'm standing here, I can see tree branches from a box elder maple right on the other side of that wall. And they were just going all over the place. Gale force wind came out of nowhere. And I kept working. And all of a sudden, thunder is getting a lot more frequent. I was stepped outside to see what was going on, and I could see that the sky was kind of this layer of overcast that looked non-threatening at all. But then there was a break in those clouds, and I could see the green, horrifying sky. And at the same time, a friend of mine's texting me saying, "Hey, dude, there's a tornado developing in your area right now. You need to get shelter." I'm in what I consider a pretty good shelter for a tornado, particularly one that comes from the north, because it's 3 walls of poured concrete, and where you see the roof meeting the wall there, this is built into a hill. If I go outside, it's dark right now, so you're not going to be able to see it, but if I go outside, that roof pitch there is only about 4 to 6 inches above the ground. So wind shear would not really be a threat to catastrophically taking the roof off of this shop. So I felt it was frankly safe to just stay where I'm at. And I kept working, and there was a point where it sounded like the rain let up a little bit, so I went outside and looked to the north, and I saw unmistakable rotating clouds that looked to be touching the ground. I was incredibly on edge, a bit scared, and figured if it shifts and comes toward me, it's going to come from the north, so I should be okay. But I would pull like, the 1990s movie Twister, where the two main characters strapped themselves onto a well pipe because it went down 80 feet into the ground. Well, this is my fly press, and it's anchored into the ground, into the concrete with epoxy anchors, and it's all a weldment. So I would have just hugged that thing for dear life and hoped for the best, but fortunately it didn't come to that. But anyhow, I felt this was safer than running outside in the tornado and going to my house, which is 100 yards away. So that was a bit terrifying. It eventually passed, and fortunately, for me anyway, it passed right between my house and my parents' house, which live 1 mile north and 1 mile east of me. But tragically, it devastated a lot of people. No lives were lost, fortunately. There weren't even really any injuries. But yeah, massive damage to trees and houses. I was helping a friend in the blacksmith shop. His neighbors were devastated with trees falling on their house, and so I was over there chainsawing yesterday, helping the community out. So I will never ever forget forging this nail header. It's not the finished product. I still need to, the handle's not going to be this long. I can do other things with that wrought iron. I'm still going to shape the handle a bit and obviously punch and square drift a hole in there. But anyhow, it's progress on it anyway. And then this was this evening's project. It is not complete, but this is my first attempt at a jump weld. 1/2-inch square bar that's forge welded to, this used to be 1.5 inch round bar, and I forged it square. And basically I took the 1/2-inch bar here, upset it. Sorry, I'm off camera. I upset it quite substantially to get a lot of mass down there, and then used a narrow cross peen to develop and pull out material on 3 sides. I wanted to leave one side flush so that it would sit flat. This is going to be a spring swage. And so I've got 3 sides that I pulled material out, flattened it, scarfed it so that they would develop and blend into the weld better. And then I heated both pieces up in coal forge, and actually did it at a friend's shop. We have a weekly gathering. Heated it up in the coal forge very, very gently, because we're talking about 2 pieces of metal that have drastically different cross sections, and because they have drastically different cross sections, they're going to heat at drastically different rates. So over here is the rest of it. So I had to very slowly heat it up until both pieces were approaching a forge welding temperature. Took them out, brushed the scale off, threw flux on there, put them back in the fire, and then slowly brought them up to a forge welding temperature. And my method of doing things is different than I see on YouTube. People on YouTube generally take both pieces straight to the anvil and then try to hammer and weld them together. I don't do that. In my experience, I have plenty of luck by, pretend I'm going to weld these, pretend that's already developed out, like this one. I put both in the forge until they're at welding temperature, and then I remove them, put them literally right on the forge, right by the fire, and I stick that on there, and I'm applying down pressure and twisting it while I'm holding the bottom one with tongs. I twist it, and you can feel it sticks, and then I'm able to pick up both of these as one unit and carefully put them back into the forge. I flux them first and then put them back into the forge. And then take another welding heat, another careful, slow welding heat, because that weld is not significant at that point. It's a weak weld, but it is enough to treat both pieces as one bar. And then I take it out, and then I hammer it, and then I, peen these edges over to blend them in to the larger bar, and it worked out quite well. I do that with when I'm going to do what people consider a drop tong weld. I don't do drop tong in the traditional sense. I put both pieces in the forge until I get them both at a welding temperature. They're of course already scarfed, brushed, and fluxed at that point. And then I simply, at the forge, just put both of them together, wiggle them, and then they're stuck. And now I only need one pair of tongs. I put them back in the forge with a little more flux on there and take another welding heat and take it to the anvil, and then I develop the weld. But that's my method to it. One of these days I'll get a video actually showing footage. Maybe I'll do that with the other end of this. So the next step for this piece, it's going to be a spring fuller, spring swage. And I'm going to upset this end of the bar, develop it exactly the same as I did here. I use a cross peen, and then I put it in a leg vise, which I got over there, and was able to flatten it out and scarf those to kind of a nice single bevel. And then I'll probably cover that on camera when I go to finish this, hopefully this weekend. And then I will have both pieces essentially in this orientation, flatten out a few inches section in the middle of it, and then bend it over on itself. The final plan with this is to, once the assembly is complete and I fold it over on itself, align the two dies so that they're in good alignment and they're both nice and flat. Got some hammer marks in that one. And then put a lag screw, a hardened lag screw like those, Spax lags, in between the dies, get them both hot, and forge those threads into these dies and see if I can make a functional lag screw forging die. That's the goal. I don't know how well it's going to work out, but we're going to find out. So stay tuned. Thanks for watching. I hope you guys hit the thumbs up button and subscribe if you like this kind of content. We'll try to get some more actual forging footage going on. But for now, catch you later, guys.